Proving congruence, hypotenuse-leg. The final shortcut to proving congruence is hypotenuse-leg triangle congruence, or the HL triangle congruence for short. This theorem states that if two right triangles have their hypotenuses and a pair of legs congruent, then the triangles are congruent. The HL triangle congruence can be considered a corollary of the SSS triangle congruence. In a right triangle, the sum of the squares of the lengths of the two legs equals the square of the length of the hypotenuse. C squared equals A squared plus B squared. To prove the HL theorem, we will use algebra. So given A1 equals A2, C1 equals C2, and angles C1 and C2 are right angles, prove that the triangles are congruent. The plan is to show B1 equals B2, which makes the triangles congruent by the SSS postulate. By the Pythagorean theorem, C1 squared equals A1 squared plus B1 squared, and C2 squared equals A2 squared plus B2 squared. First, we solve for B in both equations. So B1 squared equals C1 squared minus A1 squared, and B2 squared equals C2 squared minus A2 squared. Then we substitute C1 equals C2 and A1 equals A2. So then we substitute them in each other's equations, and we get that B1 equals B2. Therefore, the triangles are congruent by the SSS postulate. Hypotenuse-leg example. Are the triangles congruent? These are right triangles, so look for HL triangle congruence. In this example, angle B and S are right angles. Segment AC is congruent to segment RT, and segment BC is congruent to segment ST. This is the information needed: right angles, congruent hypotenuses, and congruent legs. Hypotenuse-leg theorem. If two right triangles have congruent hypotenuses and a pair of congruent legs, then the triangles are congruent. Here's the theorem in action. Given that angles B and S are right angles, and segment AC is equal to segment RT, and segment BC is equal to segment ST, prove that the triangles are congruent. So we're given that those two angles are right angles and that these segments are equal. Therefore, these segments are congruent to each other. AC is congruent to RT, and BC is congruent to ST. Therefore, due to the HL theorem, these triangles are congruent. Proving triangles congruent. Definition. Two triangles are congruent if and only if corresponding angles are congruent and corresponding sides are congruent. Fortunately, to prove two triangles congruent does not require showing all 6 corresponding congruencies, but only 3. SSS congruence needs 3 pairs of sides. SAS triangle congruence needs 2 pairs of sides and the included angles. ASA congruence needs 2 pairs of angles and the included sides. AAS triangle congruence needs 2 pairs of angles and non-included sides. And HL triangle congruence needs pairs of hypotenuses and legs in right triangles. Note, SSA is not a justification for triangle congruence.